Right, so I'm going to start boring out this worm wheel next. But as I mentioned before, this is very hard to hot limit 3-jaw chuck onto the gear teeth, so we need to make up an adapter sleeve to go over that in the chuck. So I've got a bit of stock here that we're going to bore out to be a nice close fit on the OD of that worm wheel. And then what we'll do is we'll put a slit into that as well so that it can clamp down when we put it in the 3-jaw and hold it nice and firmly. So we'll just knock that little adapter up first and then we'll get on to the boring side. Right, I'm going to set up to machine the OD on this adapter ring that we're going to make up. I've already faced it and I've put some centers in on either end. So I'm going to make up a driven center. This is a little technique I learned many years ago in a heavy machine shop I used to work in, and I was watching one of the blokes, big Dutchman called Jerry Buzzin, and he was machining up a heap of pins for a big ore bucket, and he had dozens of these pins to do the final machine. And he used this particular technique. There was no drive dogs used at all. He just sandwiched it between centers, the driven center and the live center, and he was knocking off a couple of mil each one to do the final finishing. So he set up his tool, did his final finishing in one cut, set up the next one, final finishing in one cut. So we machine this center so that it's dead set concentric to the chuck. As it is there now, so I'll reset up and we'll put the we'll put this between the driven centers and we'll have a go at machining the OD on that. Righto, we'll see how we go. So we're just going to take a very light lick off this. Righto, and that's got that trued up beautifully to the sides. So we'll set this back up in the 3-jaw and we'll start boring this out to be a match fit for the worm wheel. But yeah, as I said, it was a interesting technique and it worked beautifully. He was able to take a couple of mils on each pass, and I've used that quite often now to just do licks over the top. It's a very quick, easy setup, especially on thin stuff like this. But on other stuff where you've got multiple shafts that you machine to a size, set the tool up once and just knock one out after the other. There's no need to put drive dogs on or leave extra length or turn the thing around with a drive dog. It just one sweep through and it's done. So yeah, that was from the big Dutchman Jerry Buzzin. I was very fortunate in those very early days to work in a big heavy machine shop. And we had a massive amount of blokes from Europe, and they were wonderful to work from. We had Samuel Lavossi, the Frenchie. We had Jose Cagias, the Spanish man. He worked on the Inky die. We had Tony Bader from Italy. He worked on the Hecate. We had Big Adolf Logo, 6'8", German. He was our leading hand. He was an absolute presence in the machine shop. Yeah, we had a very wide variety of blokes that had worked all over. And it always used to get under the skin, particularly Europeans. They spent up to 10 years working their way up to become a first-class machinist from a third-class machinist when they come out of their apprenticeship. But here in Australia, as soon as you came out of your apprenticeship, you were put on to first-class machinist wages. So that always used to get under their nose that young kids out of their time got paid the full machinist rates. But yeah, they were the old days anyway. Alrighty, we'll set this back up in the chuck, and as I said, we'll get this bored out to size to suit that OD of that worm wheel, and we'll start doing the bore on that. Alright, so this is my 2-inch drill, and I've got that in a 3 to 4 adapter to fit up inside the tailstock. I've used this quite a lot. It's a pain to try and grind because I've only got a 3/4 wide or 5/8 wide grinding stone, so it takes a little bit to try and get this ground up if you chip it, but it's a handy size drill to have, just to take some meat out. Right, we'll just pull that out, so if I take that all the way through, it's going to take a chunk out of my my chuck. So we'll finish it up there. I might just turn that around and finish that drilling off from the other side. And then we'll set up for boring. So we'll come back when we're sort of getting close to the finish of that. Right, so we finished machining on the ring. I've already cut the slot in it. I machined it probably about 5 thou-ish, or not quite oversize, to fit the worm wheel, and I was expecting that to pull in a fair bit when I cut it, and it certainly has. So it's a bit of a tight fit in there now, so I'm going to have to just give that a light press fit, get that into place, and then we'll set that up in the 3 jaw, and we'll start doing our machining operations. Get that bore done, which will be this bore up inside here. So we'll get that done. And as I said, this bore here will do when we get it assembled onto the shaft, so we can actually machine that dead concentric with the shaft. Alright, so I'll get that set up in the lathe now, and come back when we're well underway with the machining. Right, we've got 0.24 of a mil to take out of the bore. That'll give us 0.01 clearance, so we'll just see how that feels, and we can hammer it back from that. So I'll just zero this out on the digi. Righto. Let's see how that's looking. Should almost be size for size, or close to. Two, three, 4, 5, 6.06 left to go. It's 0.03. Right, that'll do it. It's a nice finish in there. That's going to go just and there we are there. Right, I'm very happy with that. That was just a very, very light size for size fit. Righto, get that cleaned up now. What I'll do next is, I'll do it off camera, but I'll take the 3mm off this, and that'll bring us back to length on that. I'm already at exactly 17mm on the depth here. That's just the OD that we had to clean up, but not happy with that. I'll take the burrs off that. Take 3mm off that, and then we'll set that up on there once we've drilled and tapped all of our holes, our mounting holes. Alright, back soon. Alright, so I'm just doing this counter bore for the crank disc, so I've touched that off. So I'm going to come in 2mm. I've marked the line here we're going to come up to. What I'll do is I'll do the final bore size when that's actually mounted on the shaft. Oh no, that'll do us. We will drill these through, tap these with the jacking screws, and as I said, I'll bolt that up onto the shaft, and then we'll just do the little tiny leak. There's only about 1/2 mil to come off on that. We'll get that back to size. Right, I'll just drill the clearance holes through on this first. I'm starting up, I've set up my digi with the PCD, so I'm starting at 90 degrees around, and then we'll drop the other 3 holes in, finishing at 330. We'll drill those through, and then we'll come out of phase by 30 degrees and drill the tapping holes after this. So I'll start with the clearance holes first. This is on a 21mm PCD. So you see 3 holes evenly spaced. I'll set up for the drilling next. We'll come back when we've done that. Alright, so we'll drill the tapping holes now. So on the digi readout, I've set that 30 degrees as my start angle, and my end angle is going to be 270 degrees. So that's one of the examples where you'll set up different start angles to divide out PCDs. Similar application to this. Tapping drill in this case is a 5mm for an M6. Right, so there for our jacking threads. If it ever gets stuck on the shaft, we can jack it off fairly easy to remove it. Right, I'll just set up now and I'll tap those out, and then we'll come back to the lathe for doing the final bore. One thing I should have mentioned before I started doing this is that I use this collar that we've machined up to get my centre from. It's actually clamped quite tight around that outer circumference there. So it was a perfect surface to do that with. Alright, I'll take that out, flip it over, and I'll remove the burrs on the other side, and then we'll set him up in the lathe. I had to set this up in the lathe and forgot that I hadn't drilled and tapped into the shaft. So just running off the same PCD arrangement that we had in the last setup. So that's 30 degrees offset, circular, so it doesn't matter. I'll just get that into place. I'll take these down about 10 mil. Righto, I'll set up and drill and tap those and set it up in the lathe again and get started on that worm wheel. Alright, we'll see how we go with this. I've got 0.06 left to come off the radius on this. I've already set the 0 point, so I know where I'm coming into on each cut. So I'll just touch off now, zero off my x-axis, and then we'll take our cut. Measure that. Oh gosh. Get new blokes out of the way. Let's just reset that again. Alright, that's somewhere near it. So we're only for 58. 7.92. .88. Alright, just a little, 57.92. 0.08, 0.04 radius. Now bearing in mind that the crank disc is going to fit on here, I'm going to be able to hand fit that. If I don't pump the tripod again, let's see how we're looking. .9. Alright, I'm happy at that. .9. I might just sag a tiny smidge. It's almost there. I know this is a rough way of measuring, but yeah, it's dead nuts on 58. Done. Now I did clock this up just to see what it was like, and it was within 0.03. So I was very, very happy with that. I did just take the skimmiest little lick over that. Matter of fact, it's only just put a shine on it, if anything, but just to make sure that that was absolutely concentric to our little drive shaft. So no, I'm really happy with that. All right, we'll maybe look at starting to put some bearings on and seeing how this fits into place. Hi guys, I've had a couple of requests from viewers asking questions about this little universal lathe tool that I use, and it's a tool that I probably do 90% of my turning with. It's very, very universal and very, very adaptable. I purchased this on eBay from a company called Williams, which are up in Deer Park, which is about 2 hours away from me. As I said, about 5 years ago. They're now out of business and no longer making these. He was selling on eBay. I think it cost around about $65 to buy that with a couple of tips in it. So, incredible value. He was manufacturing these for the mini lathes. He was also manufacturing these for my size lathes, and he was also doing for much larger lathes. This actually fits in my lathe, and I use this for real heavy stuff. It's a fairly simple concept, and I was concerned when I first purchased it about what the rigidity was going to be like, given the fact that the way that this head is actually held into place. But when I did get it first, I gave it some pretty nasty intermittent cutting on some chrome moly steel with a keyway in it, and it just ripped through it without an issue. So my concerns about rigidity were allayed with the tool. Still got to be careful with my setup on the actual tool post itself, but as far as the tool went, absolutely wrapped with it. With this tool, we have a locking mechanism in the back here. I'll show you this one here. This is one that I purchased 12 months after I bought this one. He was no longer making them, but he was able to put together one to actually get parts, so that from the parts that he had, he was able to make up a complete one, bar the locking screw at the back. But basically what it's got is a long dowel pin down inside. That fits down inside there. The head is very simple. Hopefully you can see that. Just a spigot on the bottom of the head that fits inside a mating hole. Sits inside. The dowel goes up inside. The screw goes up behind it and locks the pivoting pin in place. And look, as far as being universal goes, I can do your standard right hand turning. I can do left hand turning. I can run my lathe in reverse and do counterboring up to 6mm. I can also do facing, and I've actually used it. I sit it in the middle there when I'm doing roughing out of heavy threads. Rip it out with this, and then come in with a high-speed seal bit afterwards. So the head comes out quite easily. Not much to the base. It's just designed, machined back so that it can fit into the tool post. It's fairly simplistic. It's just got a hardened square-headed bolt on it. Fairly long one, obviously. Up inside there we see the dowel. So I reckon it's a fantastic tool. I don't think he sold many of them. Obviously something new, people might have shied away from it, and he didn't sell a great deal of them. Obviously some people might be a bit dubious with something new, particularly like this, and think, yeah, it's not going to work, but I tell you what, it's fantastic. With the dual head, you can set up two different radius tips on it. So I run a 0.8 in one side, and I run a 0.4mm radius in the other side. So these are the DCMT type inserts. These are the 07s, the smaller ones. They're the bigger ones, obviously. And this thing here is just absolutely rock solid. Absolutely rock solid. So 1, 2, 3, and 4. So there's only 4 parts to it. Very, very simple design. So wouldn't be that hard to make one up if you had to. Would not be that hard at all. So, but as I said, I've been running this for 5 years now, and it's copped an absolute hammering, and yeah, it's as rock solid as the day I bought it. So, all right, I hope that's given you guys a little bit of something to have a look at. Maybe get some ideas going on on that particular tool. But as I said, for me it's an absolute winner. Alright guys, we'll get back to the machining.